Your development team is busy. Everyone is working at full capacity, but somehow features still take too long to ship. 2 weeks of work turn into four. A developer says that their part is finished, but the feature still isn't ready. Deadlines move and the roadmap keeps growing. And eventually, someone asks the obvious question: why is development so slow? The first reaction is usually to look at the developers. Maybe we need better engineers. Maybe the team isn't productive enough. Maybe we simply need more people. But after more than 10 years of building mobile applications, I've learned that this is often the wrong place to start. In many cases, the developers actually aren't the bottleneck. The system around them is. Hey everyone, I'm Aleksa, CTO and co-founder at Aetherius. Over the years, we've worked with enterprises and startups building, maintaining, and scaling mobile products. And one thing we've seen repeatedly is that the development teams can be full of great engineers and still move much slower than they should. So in this video, I want to show you 5 of the most common bottlenecks that slow development teams down. Some are technical, some are organizational, and some are so normal inside companies that people completely stop noticing them. So let's get started. Poor planning. Let's start with something that doesn't sound very technical: planning. One of the biggest reasons development slows down is that developers simply don't have everything they need to complete their work. Let me give you a very simple example. Imagine an Android developer starts working on a new checkout feature. The UI is ready, the task is assigned, development starts. 2 days later, the developer reaches the API integration and realizes that the backend endpoint isn't finished yet. So now they wait. But of course, they can't just sit there doing nothing, so they pick up another task. Then the backend becomes available. Now they have to stop doing what they are doing, return to the checkout feature, and remember how everything works. Integrate the API and continue. Then another problem appears. One of the requirements wasn't clearly defined. What happens if the payment fails? Should the user stay on the same screen? Should we retry automatically? Should we show different message for each error? Nobody knows. So development stops again while product design and engineering discuss it. Then, while all of that is happening, another feature suddenly becomes more important. Priority changes, the developer moves again. And 2 weeks later, management looks at the original task and asks, why isn't this finished yet? From the outside world, it can look like developers spent 2 weeks building something that should have taken 5 days. But that's not actually what happened here. They spent 5 days developing, and the rest of the time is spent waiting, switching tasks, clarifying requirements, and coordinating with other people. We've seen this type of situation so many times. And it's especially common in larger organizations because mobile development depends on so many other teams: backend, product, design, QA, sometimes legal, sometimes third party providers. So, before saying our developers are slow, I always want to understand how much uninterrupted time did they actually have to develop the feature. That is a huge difference. Good planning doesn't mean that every detail needs to be perfect before development starts. That's pretty unrealistic. But the team should at least know what they're building, what they're dependent on, and whether those dependencies are ready. Because if your mobile developers spend half of every sprint waiting for someone else, hiring faster developers isn't going to solve the problem. Code reviews. The second bottleneck is one that CTOs and managers often don't see: code review. Let's say one of your developers finishes a feature on Tuesday. From their perspective, the development is complete. But then they create a pull request, and only one senior engineer on the team is allowed to review that part of the code. And that senior developer is already busy, so pull request sits there. Tuesday passes, Wednesday passes, and on Thursday, the senior developer finally reviews it. There are 5 comments. By that point, the original developer is already working on something completely different. So now they stop, Open the old task, read the code again, remember why they made certain decisions, fix the comments, and push another version. And then wait again. The code might have taken 1 day to write, but getting it through the entire development process took 4. This is becoming especially dangerous when the team grows. Imagine you have 8 engineers, but one of the developer still has the final say on what goes to production. On paper, you have 8 developers, but for certain parts of the product, your entire delivery speed is actually controlled by just one person. That's a bottleneck, and there is a good research behind this as well. Dora has found a strong relationship between fast code review and better software delivery performance. Google's own engineering guidelines also make an important point. The goal isn't to optimize how fast one developer can write code. The goal is to optimize how fast the entire team can deliver software together. And I think that's the right way to look at the development productivity. A feature doesn't create any value just because the developer has finished writing it. It creates value when the user can actually use it. So the process isn't task to code, it's task to code, to review, to test, to release, and then finally to production. If one of those steps is slow, your entire process is slow. We've seen teams where senior developers become bottlenecks without realizing it. Everyone depended on them. They reviewed the important code, they answered architectural questions, they helped junior developers, they fixed production issues, and they joined all of the technical meetings. And at some point, every important task was waiting on the same person. So, the solution isn't always to remove that senior developer from reviews. It's quite the opposite. You want their expertise, but you need to spread the knowledge across the team. Define clearer ownership, create review standards, and allow more people to make decisions. Otherwise, your best engineer can accidentally become the reason why everyone else is waiting. Context switching. Now, let's talk about something almost every developer has experienced, and it's context switching. Imagine that your morning looks like this. At 9 a.m., you're working on authentication. At 9:30, you have a daily stand up. At 10 o'clock, someone reports a production bug, so you come and investigate it. At 11, there is a meeting with the backend team, and at 11:45, you return to authentication. You open the code, you try to remember where you stopped, and then lunch. After lunch, there's another meeting. Then someone messages you about an old feature you worked on 6 months ago. At 3 p.m., you finally return to authentication again. You have been technically working since 9 o'clock, but how much of actual focus development did you do? Maybe 2 hours. Microsoft has studied this with professional software developers. One of the patterns that they found is that developers associate productive days with being able to complete meaningful work without constant interruptions and task switching. And that makes complete sense. App development requires a lot of information to be held in your head at the same time. You need to understand the feature, the architecture, the edge cases, and when you're interrupted, you don't simply continue 1 minute later with the same level of focus. That's why I don't like measuring engineering productivity based on how busy people look. A developer can have 8 hours completely full of activity and still produce a very little meaningful output. There is a huge difference between being busy and moving the product forward. We've actually had situations where engineers could make much faster progress simply because we protected their development time better. Fewer unnecessary meetings, clearer ownership, and better asynchronous communications. Less jumping between unrelated tasks. Of course, some interruptions are unavoidable. Production bugs happens, clients have questions, things change. But if every developer is working on 5 things at the same time, I would say your team has a bigger problem. Lack of documentation. Here's a sentence that almost every development team has heard. Ask Marco, he built that. Or don't touch payments until Anna comes back. This is another bottleneck that often stays hidden for years. As long as that person is available, everything seems fine. Someone has a question, they go and ask them. Problem solved. But over time, more and more knowledge starts living inside one person's head. Why was this architecture chosen? Why does this API behave this way? Nobody knows except one person. Imagine they go on vacation for 2 weeks. Development slows down. And imagine that they leave the company. Now you have a much bigger problem. We've actually seen this particularly when joining mature projects. Sometimes you open up part of the codebase and something looks unnecessarily complicated. Your first reaction is, why would anyone build it like this? But maybe there was a very good reason for that 3 years ago. If nobody documented that decision, the next developer needs to become an archaeologist. They read old commits, old tickets, old Slack messages, maybe even ask someone who remembers. All of that development is time. And it becomes even more expensive when you start adding new people. Companies often think we'll hire 3 developers and increase our capacity. But if the codebase has poor documentation and critical knowledge belongs to 2 senior engineers, those new developers immediately become dependent on the people who are actually already overloaded. So instead of increasing capacity, you temporarily reduce it because your senior developer is now spending time onboarding everyone else. Documentation doesn't need to mean creating 500 pages nobody will ever read. Good documentation can be simple. Why did we make this architectural decision? How does this critical flow work? Who owns what? The goal isn't the documentation. The goal is to make sure that your company doesn't depend on someone's memory. Technical depth. And finally, probably the biggest technical bottleneck, technical depth. It usually doesn't happen because developers don't care about quality. It happens because meeting deadlines are more important. So developers take a shortcut. They tell themselves, I'll clean up this later. So every project has technical debt. The problem starts when later never comes. The next sprint has another feature, then another, and suddenly a shortcut that was supposed to live for 3 months has been in production for 4 years. Now every developer has to work around it. And this is exactly where technical debt becomes more expensive. Not because the code looks ugly. Most executives don't care whether the code looks beautiful, and they shouldn't. A feature that should take 3 days takes seven. A developer spends 2 days understanding how something works before making a tiny change. Then testing takes longer. And eventually, you get into a very strange situation. Your team gets bigger, but delivery gets slower. Slack company had a very interesting example of this. Their mobile teams publicly talked about reaching a point where the technical debt in their Android and iOS codebases was slowing development enough that it started affecting the product roadmap. Think about that. Technical debt was no longer an engineering inconvenience, it was influencing what the business could deliver. They had large monolithic parts of the application, complicated dependencies, different architectural patterns, and code where changing one thing could affect something completely different. And that's exactly the point where technical debt becomes expensive. We've seen similar patterns in mature mobile projects. The app works, the users are happy, nothing looks broken from the outside. But inside the development team, people know. There are areas nobody wants to touch. And this is why I think technical debt should never be treated as the developers want some time to clean the code. That's a terrible way to explain that to business. Instead, ask this: how much longer does it take us to ship because of this? How much bugs do we create? How much time do new developers need to understand the project? How much engineering capacity are we losing every month? Now, the technical debt becomes measurable. And once you measure the cost, you can decide whether fixing it actually makes some business sense. So, is your development team actually slow? If your mobile development feels slower than it should, I wouldn't immediately start by saying something like, do we need better developers? And I definitely wouldn't immediately ask, how many more developers should we hire? First, I would look at the system. Are developers constantly waiting for backend design or product decisions? Is code sitting in review for days? Are engineers jumping between five unrelated tasks? Does important knowledge live inside one person's head? Has the technical depth made every new feature harder than the previous one? Because if those are the problems, adding five developers can sometimes make things even worse. You'll simply have more people waiting. That's it for today's video. And before you decide that your team simply needs more developers, take a closer look at what's actually slowing them down. Maybe the problem isn't the size of your team. Maybe it's the way that the team works. So, what's the biggest bottleneck in your development process right now? Code reviews, too many meetings, unclear requirements, or technical debt? Let me know in the comments. And if you find this useful, subscribe for more content about mobile development, engineering teams, and the decisions that make development faster or slower. Thanks for watching and see you in the next video.